to be here to our last webinar of 2022. Sorry. I'm Cristina Carini, account manager and SPS, and together with my colleague of training staff and consultancy staff, I am pleased to introduce you to the theme of this event. We have decided this theme after, we have decided this topic after a meeting with some customers, and so we are very glad to receive your suggestions, and so please go on. Okay. This is the agenda of the webinar of today. And at first, I would like to devote some minutes at SPS as a firm. SPS has been founded in 1994 and has been active in the world of statistical analysis and SPSS technology ever since. We are Gold Business Partner of IBM and a certified entity to give direct support to our customers on SPSS. At SPS, we take care of our customers from assessing the need for analysis to choosing the most suitable statistics for data analysis solution to training on its use. We collaborate with public administration, association, company, university, and so on. And why do we talk about statistics for data analysis as a solution, a value solution? Statistics for data analysis combines with our expertise in the world of statistical analysis and SPS statistical engines. Okay. In addition to supporting our customers directly, we sought tools that would allow us to share our knowledge. And so the first operational tools that I'm pleased to introduce you is the Launchbox. Launchbox is the gateway to the statistical world. It is your dashboard to keep in touch with SPS proposal for training, new features, opportunity, and so on. Downloading Launchbox, you download automatically add-ons too. Add-ons are additional features built in natively, strengthening the tool statistics for data analysis. And today, my colleagues, Arianna Zellino, will show you split string add-ons. In Launchbox, there is a section where you could see our next webinar event that we have set in our calendar. And there is an area with the recording of the appointment available for our customers. Also available in this area is a form for submitting methodological questions, which will be answered by our support staff. In the Launchbox, you will find some additional tools such as the Data Access Pack and License Manager for managing concurrent architectures of SPSS statistics, and the user manuals in English mother tongue. Together with the add-ons, SPS Factory has developed some premium modules, such as UDEM modules to define cutoff of a ROC curve. And this is the screen that you find in our Launchbox when you would like to download the UDEM modules. And P-score modules too, for propensity score matching techniques. And this is the screen of P-score in Lunchbox too. In the last autumn, we have presented our app, Statistics for Data Analysis, that it's useful for you to look at recording a webinar in mobile way and to reach the area of tips and tricks with some smart suggestion for statistics for data analysis use. These are some information that you find in our app and of course for downloading it from App Stores and Google Play. As value-added services, of course, we are proud to talk about our SPS service program that assists our customers in technical needs and in for some problems, such as to change the solution from a PC to another, and so on. Thanks to our expertise and an ongoing dialogue with our customers, a few years ago, we proposed our own statistics for data analysis configuration, designed to directly address the analysis needs of different fields, such as socioeconomic, medical, environmental, and so on. We also have online training classes, and in recent years, we have strengthened our course offering. I would love to become your partner for training on SPSS as well. Okay, this is our SPS Galaxy with different operational tools. Okay, at this point, I will give the floor to Arianna for the core of our meeting. And if you have any questions, please write them in our question and answer area. And we will try to have the time to answer at the end of the appointment. Arianna,
Yes.
I give you, okay, I hear you well.
Okay.
I give you the role and have a nice webinar. Thank you.
Thanks. So good afternoon, everyone. I will also share my other two applications we are going to see in this webinar today. Okay, I think I am all set. So the main idea of this webinar is sort of provoking topic of discussion, since we are going to compare two very different tools. A tool that I'm pretty sure most of you use as a daily working tool, such as the spreadsheet, and the a statistical analysis tool, which some of you may not be too familiar with. So the main idea of this webinar is to find together the similarities between these two different type of computational tools, but also to discuss the dissimilarities and the advantages that statistical packages may have on a common spreadsheet. So this will be also the occasion to discuss a little about data preparation, which is something that we normally do and generally require a good deal of time, since very often data that we need to analyze are not already in a form that we can easily use. So we will give some example of this. And this will be also the occasion for introducing some function of the very complex and rich analyze menu of the statistics for data analysis. So we will start from here. This is an Excel file that we will play with during this webinar. The Excel file contains information about the so-called brownfields. Brownfields are contaminated soil areas, which are unfortunately very common in many urban environments. I think this is a list, I don't know how updated from Massachusetts, so is an example coming from US. And it's an archive of all the known contaminated sites which are present in different towns in this state. So this is just an example. I will show you directly with the Excel spreadsheet. And I'm pretty sure that you may have other example of this kind when you use the spreadsheet as a database. So you have all your data probably also entered in the Excel spreadsheet, and therefore, quite reasonably, this is probably the tool you are going to use to run the first preliminary exploration of the data that are here contained. So to give you other information about this file, we have a little more than 1,200 records, a little less than 1,300, and we have a different type of information. We have some information that are present in the form of string, since we have a text value, for instance, the name of the town where the brownfield is located. And we have also some quantitative information. For instance, we have the area of the brownfield in terms of acreage, because we are using here American units. First characteristics that first question that we might ask while considering this file is whether we have the same quantity, the same number of brownfield in all the cities and towns that are present in this archive. And we would probably try to answer to this question by using the filter tool of the spreadsheet, which is showing that we have a huge number of different attributes of this town variable. Another characteristics that I wanted to underline here is that for the Excel spreadsheet, the text are not so-called case sensitive. So for instance, here we have the town of Acton, which is written with only the initial as capital letter most of the time, but is also written at case number 7, all in capital letter. Something like that, if analyzed with the statistical packages, would lead to different frequencies. So this would be, for instance, something requiring a cleaning of the data, because it would be needed that the same town be always written using the same method. Okay, so going back to the presentation, the thing that we are going to compare only visually may look very similar. In fact, in this slide, you can see side by side the conventional look of Excel spreadsheet and the conventional look of a data file in statistics for data analysis. I can also show this in real. Okay. as I said, the look is apparently similar. However, we can see here in the data editor of the statistics that we have something that look like multiple spreadsheet. So we are used to see things like that in the Excel file because we can have multiple copy of different spreadsheet. Unfortunately, here the two view are not exactly the same. In fact, if the data view is probably the exact copy of the Excel file we have just considered, the variable view instead is more similar to the structure of the table that we would have in a database if this file, instead of a spreadsheet, was a database. In fact, in the variable view, we have all the information which concern the columns, the different columns, which are present in the data view. So for instance, if I double click here, the variable, this is called variable in statistics for data analysis, and the name of this variable is town. And it is indeed a variable because we have a different name of town in this data set. So if I double click here on the heading of this column, I am sent to the variable view to the row number 3, where I can find all the information about this variable. So here I can read that this is a string, so it's a text with 21 character as width, and also other characteristics that I am not going to introduce in this webinar. If I do the same job here in the area total acreage, that here I have also converted into a quantitative variable. You can see this is simply the Excel spreadsheet which was imported in the statistics for data analysis. And since, and this is something that may very often happen with spreadsheet, because there is no control for the whole column. Each single cell is independent from the other. So it's absolutely possible to have a cell containing not only numbers, but also the unit of measurement. Like here in row 21, we have 8.6 acres. So when this variable was imported, statistics for data analysis converted this into a string, because otherwise the text that we have in this record wouldn't be compatible with all the other characteristics. So all the numbers here are just read as characters. So this is actually a string variable too. So I had to convert that by eliminating the text and the character which were by mistake introduced together with the number. So if I go here on the quantitative variable, and I can tell this is not a string because the symbol that is associated to the variable has no A character. The A character is the symbol that the software attributes to string variable. So if I go here, this is the variable number 14, and I know that this is a numeric type. We may have different type of numeric type, and the comma and dot format are type which are specifically designed to deal with the fact that with some system For instance, the Italian system uses the comma as an indicator for decimals, while for the international system is the dot, the indicator for decimals. So whenever we have numbers having the comma and the dot alternately present, we can use this format to attribute the right nature of this number. So I can see here that in this variable, I have the possibility to have 3 decimals. And this is the reason why all the numbers are shown with 3 decimals. And you can see that we have the dot here as indicator of decimal. And this was consistent with the initial acreage that is given in American unit. Okay, so this was a very brief overview of the difference between these two tools. But then why I'm here to let's say, convince you to try to abandon sometimes the tool that you probably use. Sorry, this was supposed to come with some animation as your conventional working tool. You can see these are funny cartoons which try to capture a situation where very often we are we fall in. So for instance, this lady is saying that the day started with many problems, and then after many hours of work, now the problems were transferred into the spreadsheet. This is for sure, I mean, this is for fun, but it's true that sometimes we struggle to use the spreadsheet to obtain the result we would like to have that is not so easy to obtain using the spreadsheet. So these are other situations. Again, this is the, let's say, the periodic trouble that may occur when you are trying to fix problem, and then you create other problem because you were trying to fix the first, and then you spend the whole day trying to fix the problem without reaching the results. And the final cartoon I like very much. We have a guy here which is tempted by an angel and a devil, and the angel say, okay, don't use the spreadsheet, try to use another tool. It will be more difficult at the beginning because you need to learn it, but in the end you will save time. And the devil is instead on the side of the spreadsheet. Oh, come on, don't leave the path you know very well. Try to use the spreadsheet again. And the funny thing is that at some point it's the devil that since the guy is resisting to the temptation of using the spreadsheet, so the devil change the temptation and say, why don't you try to use a statistical tool? And it's also mentioning some function of the tool I'm going to present, like the recording and stuff. So the main message here is that sometimes spreadsheet can really be difficult when you need to fix problem for a data preparation which are not so easy to obtain. And I think the best way to present that is to make some examples. So starting from the file we just saw, we have in this 1,300 brownfield different type of contamination. And this is an archive, so we have the information about the different type of pollution that were found in this area. And so if our analysis was aimed to define which is the most diffuse type of pollution, this wouldn't be so easy to show using the spreadsheet. Since the spreadsheet is a tool that is meant and it's very effective to make calculation, which can be also linked from one field to another. This is the main job of the spreadsheet, and probably the statistical package is not able to be as efficient as the spreadsheet in doing this job. But on the other hand, when you are instead trying to use the spreadsheet to recode quickly and to report quickly the data you have in your data set, this is not the job that the spreadsheet is most efficient to do. So we will start with this question. And we will also answer to another question, such as if the area of this brown field are all the same, or there are some areas which present the largest contamination. So I will abandon now the PowerPoint, and I will work from here. So the first question was about the pollution, the type of pollution affecting the single contaminated site. And we have this column here, which is called COC, chemical of concern, which is listing for all the situation where it is known the type of pollution that is present in the area. And the thing is that this information has been recorded as a string where each pollutant is separated by a comma. So even we could do a frequency analysis of a field like that. I can show this. So I will simply request a frequency table of this variable. But this frequency table will be extremely long and not very synthetic, because for many reasons, for instance, you can see here the term chlorinated solvent is present here, both as a capital letter and as lower letter. So the statistical packages see this as two different events, and so it counts them separately. Also, the second one is different, as you can see, because the S of solvent is capital letter. So the first need we would have before doing this analysis would be to make homogeneous this redundant expression of the same pollutant. And we can very quickly do that using a compute command, which is not only a computational tool, but may also be a recoding tool. And there are many different functions available for different type of variable. I will create a new COC variable that will be clean. And I will use, to do that, under the function group available for string, the function upcase. I have two different operators which could be useful in this situation. Upcase normally transform all the characters in the string as capital, while the correspondence function that is lower would instead transform everything as lower. So today I will use lower, but they are, for the sake of the statistical analysis, they are absolutely equivalent. And I will create this new string. So it's very important that I define the nature of this new variable I'm going to create using this command. And to be sure not to lose some part of the text, I will put here a wide width for this field. I will use 70 to be pretty sure. Okay, so I will execute this now. And at the end of my table, I will see the result of this. So now, in order to count properly the frequency of each of these pollutant, which hopefully now should be homogeneously defined, I may use an add-on which was cited before by Christina, and is present here under the data menu. So this is the position where you can see all the add-ons that were installed using the launch box. And I will use this split string that is able to split a string variable by a split character. So here we know that the separation between different type of pollutants is the comma symbol. So I will use here the COC clean, and I will define that my split character is the comma. And then I need to define here the number of output variable which I expect. So I know that the longest string I have here is made by 10 different pollutants. So with 10, probably this would be enough. Also, the add-on is suggesting as length for this output string variable 50 characters, and we will leave these default settings. So you can see here I have now in this data set a set of 10 other variables, and I have also an additional variable here showing any potential text that was left out by my setting of 10 new variables. So we can quickly check whether this testo rimanente is empty, as should be. Okay, so I will do another frequency analysis of the testo rimanente. And you can see that the frequency table is absolutely empty. So our guess was right. So the longest pollution string was of 10 different pollutants. So I'm deleting this now unuseful variable, and I will show another interesting function that is available in statistics for data analysis. I can consider these 10 variables as combined as multiple set of variable, and we can do this under the table under the analyze menu. We have a tool that creates custom tables, and within these custom tables I can also define the so-called multiple response set. So I may define this COC clean 1 up to clean 10. I'm not selecting the original one because I want the one separated. And these are categories. And I can define a new name for these new variables, which would allow me to count, for instance, lead as pollutant in all the situations where is present, because lead could be present in clean 1 or in clean 5, but I wanted to know the overall frequency of lead as pollutant in this data set. Okay, so now I am adding this new variable which I just defined using this set. And this is in the output, the table which remind me how I define this variable. And the interesting part is that I can use the table for this multiple choice set, and I can put my COC all as a combined variable, and I may also show here a different variable which could be cross-tabulated with this one. So for instance, I will use the former use as column variable and displaying the row total and the column total. Okay, so now the software is running the analysis. Okay. So we can see that now we have a very long list of the different pollutant, and we have a column, probably the column at this stage was even too much. Let me close this. Okay, we have as column the former use of the site, for instance, factory. Most of these brownfield are former industrial site. This is not, again, not a surprise. So since we wanted to see at least at first glance, let's say, which was the most diffuse type of pollution in the area, I can also create only a table showing this only the frequency of the pollutant by also adding also here. Okay. Apply to selection, and now I am creating the table. So I can see that there are many records where I have an empty combination of that. This is because probably the Excel spreadsheet had some cells that were activated even though they were empty. But we are more interested in looking at the highest frequency that we can find in this combined table. So we can see, for instance, that benzene is one of the highest frequency, as chromium and chrysene. So even though we are still having our time in reading such a huge column, and another recoding would be probably needed to better underline the most diffuse pollutant, but we can see, for instance, here that lead is present in 88 brownfield, so it's one of the most diffuse as the hydrocarbons or as the metals. So you can see that very quickly, by using one of the tools that are available, I was able to read to the information of that string, very long string separated by comma, list of pollutants. I am going to show you also another functionality. And this time our question will be, which is the largest contamination? We have the field of the area, which refer to the single brownfield. And I may use this time a graphical tool to explore the distribution of this variable. And so I'm using a box plot to do that and select the total area. Okay. And for instance, I may decide to put here the site name as label, which will be later useful to see very quickly which are the largest or the smallest, the outlier of this brown field. Okay. So I have a very weird box here, and this is because in the distribution of this data we have situations that are exponentially different. So to show better, here I am deleting the label. Okay. Okay, so you can see now the box is not very clear to see because it is totally pushed down by this huge range of areas which refer to our records. But I can easily convert this axis that is now linear into a logarithmic scale. And if I do so, I will be able to see the box plot more clearly. So this is the logarithmic scale, and you can appreciate here the shape of the box plot. The box plot is made by the three quartile. The central line is the median, while the lower side of the box is the 25th percentile, and the upper side is the 75th. So within the box, in this range of areas, from roughly 1,000 to 10,000, we have 50% of our brown field. And this dot here and the stars here are the outlier. In fact, the box plot consider outlier all the records which are far from the so-called upper fence. This is the 75th percentile. If I prolong the height of the box, which is a statistical measure that is called interquartile range, because it is the difference between the 75th percentile and the 25th. So if I use this as a unit of measurement, and I can see that this dot here is far from the upper fence more than 1.5 times these sides. So this is considered an outlier, but it's not so extreme. While the star here is an extreme outlier because it's far from the upper fence more than 3 times this size. So the box is also able to show us the presence of outlier. So I took away the label, but I will where is okay, I will do that from the previous okay, and logarithmic. So I can see here that the site of Fort Devens is one of the largest. In fact, it is a site of national interest in US, and all the other are still outlier in this logarithmic scale, but not as extreme as the Fort Devens area. So now the other very quick transformation I wanted to show you that still we don't know how to do is whether within the same time we have more or less brownfield of the same size or not. So we know from this distribution that there is a huge variability between case to case. It would be nice to have the possibility to analyze this within a single town and to evaluate each of this area of brownfield for the total brownfield area for that town. This is very easy to do using a tool that is called aggregate, and you can find aggregate under the data menu. And we can aggregate this using the town name. I'm using the town clean since also the town had some problem with capital and lower letter. So this was already clean by me, exactly as I did for COC. And here I can use the area and I can change, since when I am aggregating by a break variable, the software is suggesting to use the mean as representative statistics. But I can also change the statistics with the function menu here, and I can choose the sum. So in this way, I will have here in my data set also the total area of brownfield within the same town. So I will generate this. And of course, this will be full of duplicates, since, for instance, these are all brownfield coming from the same town. But this will be extremely useful to create a new variable, which we will call percent overall area. This will be a numeric variable, and I will take the total area multiplied by 100 and divided by the sum of the brownfield area within that town. So in this variable that we just created, there is the information about the provenience town. And this is the area of the single brownfield. Okay. So I can see in this new column that have been created that also here there is a range of situation, and the distribution of this brownfield in terms of area that is interested is not exactly the same. I can use another statistical analysis tool to investigate this variable we have just created. I will use, for instance, explore. Okay. This is a command which will generate a very long list of statistics that describe the distribution of this variable. But I have also the possibility of creating some plots. One is still the box plot, and the other plot we are interested in is the histogram. And I can also launch from this explore command a normality test conducted over that particular analysis. Okay, so this is the table of the statistical descriptives I was mentioning before. So I can see from here that the mean of this percent overall area is little more than 20%. However, if I compare this mean with the median, I can see also from here that this distribution is probably very asymmetric. In fact, the median is much smaller than the mean and also is outside from the bounds of the confidence interval for the mean. I can also find another confirmation of that. I have this skewness coefficient, which is much larger than 0. And it means that the distribution of this variable has a long tail on the right side, meaning that there are for sure some outlier in the range of the high values. Okay. The test of normality say something similar, because it's also rejecting the null hypothesis that the distribution of this data is normal. And if we look to the histogram we have just obtained, we can agree with that. And the box plot is also showing a very asymmetric situation, even though we don't have a very large outlier, because all the dots are depicted as dots, not as a star. So it means they are anomalous value, but not extreme outliers. But still, the median is not at the center of the box. The two whisker of the box, which represent the not outlier minimum and maximum value, are also of different size. So this is a situation where to obtain possibly obtain a normal distribution, we should consider to apply some transformation. And this is something that we should check, because we have also here this increasing frequency around the 100%, which is probably another atypical situation. But probably here applying a log transformation, a logarithmic transformation to the value, we would make this variable more symmetric, and therefore this would allow us to use central tendency, the mean as central tendency indicator. Okay, so we are almost at the end. I will simply quickly show this log transformation. And I will use the log 10 to log transform this value. And as rule, normally, instead of using the log x transformation, it's more convenient to add 1 here, so to make transformation for x plus 1, since in this way the potential 0, which could be present in the data set, are maintained also after the transformation. Okay, so now I will run again the previous analysis, but this time I will use the log transform variable. I can see that someone is not able to hear. I hope that all the other can still be able to hear me.
Yes, Arianna, we hear you very well.
Okay, so we have obtained another weird distribution here, but the thing is that now the distribution, although not normal for sure, but is symmetric. In fact, if we have a look to the descriptive table, we can see that the mean and the median are not so far away this time, even though the median is still outside from the confidence interval of the mean. But this happens also because we have a very large sample size here, more than 1,000 observation. So this create a very little, very small standard error and a very narrow confidence interval. Okay, I think I will stop here also to give you the chance to ask question. And I don't know how we will proceed for that. Cristina?
Okay. Yes, Arianna, we received 2 questions.
Okay.
I read you the first one. Does SPSS keep a script or do file to keep the commands used?
Absolutely, yes. I will quickly show from here. So this is the output, is the environment where statistics send all the table we are requesting, but also all the communication. And we have this log here, which is a recap of the script of the command we just used. So I have this information here in the log, which is always present in the output. And I have also for the command which generate table or chart, there is a hidden object that is called notes. And within the notes, there are many other useful information. The first useful information, and this is something required because in statistics for data analysis, the data file and the output file are not necessarily linked. While when we are using the spreadsheet, very often we put the report with the summary table or the summary chart together with the data file. In the statistical packages, this is normally not the rule. So it's very important also because in the same output you may have analyses that were based on different data file. So with these notes, you have the information about which was the data file you used to run the following analysis. You have also another information that we didn't use in this example, whether we were filtering data or weighting data. In this case, we have a none here. And even more importantly, we know from this hidden table the number of rows which were present in the working data file when we did the analysis. So if in time that data file was updated and now we have 2000 record, opening these notes that is always present in every command, as you can see, but is normally closed because the software show as default the object which can be printed. Now it's very rare that someone print fully the output of the statistical analysis. But anyway, you can always decide what to show and therefore to print in your output by opening and closing the symbol of the object of the output that you can see in this browser environment. And this notes is always there, as I said, for all the command. And another important feature you may have here is this syntax field. This is the real language of statistics, and this can be used in another environment which belongs to the statistical data packages. when we open the software, we normally start the process from a data editor, but we can also here open instead and use instead a syntax environment. Syntax is basically a notebook, a text notebook, but when we paste here the command I was copying from from this table here, from the command, this is the syntax which generate the following table. So I can always retrieve the command I requested, and using the syntax I may simply run again the same table over a file that maybe has been updated, and therefore this analysis can be updated too.
Okay, Arianna. Another question, is it possible to begin your analysis directly in the do file script?
Is it possible? Can you repeat the question
Yes, of
again?
course. Is it possible to begin your analysis directly in the do file script?
You mean that you have already the list of the instruction and you want to start from there? Yes, you can do this because if in your list of instruction the very first command is open that file and do the frequency table and do whatever you need to do, you may simply open the syntax as I show, and the software will repeat all the instruction that you have previously defined. And this is something extremely useful when you need to run periodically the same type of analysis over a data set that is also periodically updated. So you save your list of instruction, and the software will even open the appropriate file and do all the steps with one single command.
Okay. Another one, how to determine the suitable statistical tests for the data set?
Well, this is a more complex question. We normally dedicate a specific webinar to that. I can say that the consideration we were doing over the let's say the distribution of the variable we were having in this data set is a preliminary step to decide that. So for instance, in this new variable which we have corrected because we have made it symmetrical, we have the possibility of using tests which rely on sample mean. So if we had, for instance, for this variable, two different regions to compare within our data set, I don't know, North Massachusetts and South Massachusetts, just to make a very stupid example. With a distribution like that, we would be allowed to use a student's t-test, for instance, so a parametric test. If instead our distribution was something like this and not and no transformation would be useful to make symmetric the distribution, then the only possibility to compare to different indicator of central tendency would be a non-parametric procedure. So to summarize, to decide which type of test, you need always to keep in mind which is your goal, which are the parameters you want to compare, and the distribution of your data is the leading point to decide whether you can go using a parametric or a non-parametric procedure.
Okay, Arianna, we have finished with the question. So if you won't give me the relator role, so I give some last information for the appointment of today, and for all the persons that write us asking recording and material of the appointment of today. Yes, we are going to share recording and on LinkedIn SPSS page, you could find the presentation that Arianna has used today. Okay. About training, we are proud to have started with online training courses, and this here you could see the first 3 modules. We are working on intro online for January 2023. We have already done the first appointment, and we had a positive feedback from the participating. About webinars, these are the topics for the next of 2023. If you have some suggestion for us, please write us using the survey that we are sending you after the webinar of today. For 2023, we are working on some new tools to share with you, and so please keep in touch, looking at our LinkedIn page, or writing us, or sign in our newsletter in order to be informed. And so please stay tuned, and if you have some question, or if you need some information, these are my references, and I will be pleased to answer to all of you. Thank you very much for your attention, and have a nice evening. Bye-bye.
Bye.
Thank you, Arianna. Bye-bye.